review of topic D. Place values, charts, disks, and counting. So, topic D is all focusing on how can we represent numbers using place value disks after we model, and how can we use that to keep track of numbers with weird values on place value charts. The first thing we'll do is we'll work through an example problem together. Sarah's mom bought 4 boxes of crackers. Each box had 3 smaller packs of 10 inside. How many crackers were in the 4 boxes? Well, the first thing we can do is draw the boxes. Let's draw a model. So it says Sarah's mom bought 4 boxes of crackers. So here's 1 box, 2 boxes, 3 boxes, 4 boxes. Inside of each box, there was a pack of 10, 3 packs of 10. So I will go ahead and draw 3 circles inside of each box. Now let's do that in red, just to have a different color. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. The green shows up better. Okay. Now, each of these packs is worth 10 crackers. So inside of each green circle, I'm going to write the value of how much is in there. Okay. So here it asks, here's our next part of this question. How much do we have in total? How many crackers do we have in total? Well, now that we've identified that there are 3 packs in a box, and each pack is worth 10, we can simply count the 10s until we get to our final number. So let's see, we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. There are 120 crackers. How many packs do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so at the end we have 12 packs, which is the same thing as 120 crackers. Place value disks make the counting up a lot easier for us because we can see the number that we're working with. Let's take a look at modeling numbers with place value disks. So in here, we have our place value charts, and we have numbers above them. Before we could use these place value charts, we need to label them. In the left side, we always start with our smallest place. On the right side, we always start with our smallest value. And the smallest value we're working with is 1s. Then we go to the next biggest value, 1 space to the left. The next biggest value from 1s is 10s, so that goes in the middle. And then the left, we go one bigger, which is hundreds. We can mirror this on the place value chart down here as well, while we're at it. So now we can look at our numbers and see what place values they contain. I'll go ahead and move these sample disks away so we can analyze these 2 numbers. What I'm going to do is I'm going to draw place value bars underneath them, so we can then split them into their place values. Okay, so just like the charts, on the right side we start with our smallest place value, and then as we go left, we go one bigger. For the 72, we don't need to have a hundreds place, well, because there's nothing there. Now that we've successfully broken these numbers up, we can manipulate them and figure out what we're dealing with. Okay, so first things first, let's represent 72 in place value disks. Well, we don't need the hundreds place for this one, so we're not going to worry about it. What we do have to do is use 10s and 1s. Okay, so for 72, it says we have 2 in the 1s place. So let's put 2 of these place value disks into the 1s place. Then it says we have 7 in the tens place. Okay, so let's do 7 in the tens place. 1, 2, 3. Let's make this smaller. 1, 2, 3, 4, 5, 6, 7. So 7 tens, 2 ones shows us the number 72. Okay, now if we take a look over here at the 427, here we have to use up all 3 places. So we could use all 3 place value discs in these spots. Starting from the ones place, we have a 7. So same thing that we did earlier, we're going to put 7 place value discs into the ones place. Yep. Let's do that one better. 4, 5, 6, 7. Okay. Now let's do it again, but this time let's look at the tens place. This time the tens place asks for 2 tens. So we can just put 2 10 discs in the tens place. And now at the 100s place, it says we need 4 hundreds. So let's do 4 in the hundreds place. And there we go. We have modeled 4 hundreds, 2 tens, and 7 ones using place value discs. Now let's take a look at what would happen if we had more than 9 in a number. So we've talked before about representing numbers in different forms. For example, what if we were, instead of representing a number in standard form, what if we asked for a number in unit form? For example, what about this, where we're asking for 100, 2 tens, and 12 ones? 12 ones isn't normal. That's a much different number than we would normally see. Before, we wouldn't go past 10 in a place value if we could help it, because, well, it made things difficult. But now, because we're using place value discs, we can see where things need to change over. So here on the left, I'm going to represent the number as the way it's written. And then here, we're going to look at what we can do to make representing this number easier. Okay, so let's see. Same as before, we have 3 place value discs. They'll have different denotated values, and then we have our place value charts with hundreds, tens, and ones. Okay, now it's asking for 100. It's asking for 2 tens. And it's asking for 12 ones. Now, 12 ones looks really messy. The space is crowded. There's a lot of overlapping. It's hard to keep track of things. So let's take a look and see if we can do anything easier with this. Okay, the weird number here is the 12. So let's take a look at the number 12. The number 12. Okay, well, 12 can be broken up into 2 parts. If we pull out a friendly number that's easy for us to use and that we can show, we end up with 1 10 and 2 ones. So instead of having to write all 12 of these blue dots, I can just do 2 of them. And then we have a 10, so instead of having to make the other 10 blue dots, I can just make an extra green dot. So let me do that right now. We're going to do 100. Well, let me back it up. We're going to start from the ones place. We're going to do 2 ones. And we're not doing 2 tens. We're not doing 2 tens. We have an extra one now, so we need to do 3 tens. And now we can do our 1/100. So just to make sure that we did this right, let's count to make sure we got it. We have 100, 110, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132. So on the left side, we ended up with 132. Now let's count on the right side to see if we get the same number. If we did, we know that we split up our numbers correctly. 100, 110, 120, 130, 131, 132. So our two sides match. That means they're the same thing. So when we have 10 of something, we can substitute the 10 smaller pieces for one bigger piece, whether we're dealing with tens, ones, or hundreds. For example, we've just shown that 10 ones, I'll do this in their place value numbers, 10 ones, 10 place value colors, is the same thing as 110. Similarly, if we count by 10 times, we know that 10 tens equals 100. So if we see something, if we are given a unit bigger than 10, we can exchange 10 to get one disk we can exchange 10 disks to get 10 smaller disks to get one disk of a bigger unit. So for example, we can change 10 smaller disks, so 10 ones disks for one 10 disk. We can change 10 tens disks for one 100s disk.